Good afternoon, everyone. Thank you for joining us. For those of you that haven't been before or haven't met me, my name is James Lucas. I'm the CEO and founder of CirrusHQ, an AWS consultancy based just outside Edinburgh, but with the team members across the UK, and also the founder and organizer of the AWS user group Edinburgh. It's great to have so many people along today. There's more people still joining even now, but it's the best event we've had the whole time the COVID's been going on in terms of virtual events. It was a fantastic turnout today. Lots of people for the first time as well. I'm really excited to have Luc along to join us today because EventBridge is my favorite AWS service of all of them, and I found it's often overlooked by more high-profile services, so it's really good to get a deep dive from someone who has used it to a really high level, possibly the biggest EventBridge user in the world, quite possibly. So I'll hand over to him in just 1 second, but just to finish off the so-called advertising piece at the beginning, we are expanding our team at Cirrus, so if you're based in the UK and interested in working with technologies like those featured today, we do have a cloud engineer role on our website at cirrushq.com. So reach out to me via here or through the website, or catch me on LinkedIn if you're interested at all. And just so questions, we've got room for Q&A at the end. So as you see on the screen, there's a question section on the GoToWebinar dashboard. So please ask your questions through there, and we'll have a Q&A section in the end. Just to briefly introduce Luc, and he'll, I'm sure, do a more in-depth introduction himself. But Luc is an AWS Hero and AWS Community Builder. Works for PostNL, so the Dutch National Postal Service, who deliver millions of parcels, tens of millions of parcels every month, if I got my figures correct, with billions of events driven through EventBridge. So really excited to hear a bit more in depth. So with that, Luc, I'll hand over to you.
All right, thanks, James, for the introduction. Let me share my screen. There we go. All right, thanks, and welcome to the talk Event-Driven Architecture at PostNL Scale. So today we will be talking about events in the context of the largest logistics company in the Benelux. And we will talk about scale and reliability and self-service and how we used a purely serverless solution to achieve our goals. As an added bonus, we'll sprinkle in some CDK at the end as well. Now, this is a level 300 talk, so I will assume that you already have some knowledge about the services used, and I might introduce some concepts that you haven't heard of before as well. Quick introduction, my name is Luc van Donkersgoed. I'm the lead engineer in the PostNL integration team. I'm 12 times AWS certified, and as James just said, an AWS Hero and community builder. My current responsibility is to design and build a self-service event broker on AWS. And we'll get into the self-service part in a few slides. But before we go there, let's look a bit at the context of PostNL. So these numbers are by the end of 2020. They've increased a bit in 2021, but they're comparable over the last year. But what we saw in 2020 is we have more than 4,000 physical retail locations. We employ more than 40,000 people, most of them, of course, in the delivery part of our business. And our mobile app has more than 6 million users. We also saw in 2020 that we still send about 8.1 million mail items per day. So those are letters and envelopes. And that was about a 10% reduction in volume compared to 2019. On the other hand, we saw that we, on average, send about 1.1 million parcels per day, and that was almost a 20% increase over 2019. And that is a growing business, and today we'll really be focusing on the parcels part. So to get these millions of parcels where they need to be, many teams and applications are working in concert. And it's my team's responsibility to provide the integrations between those teams to make sure that the data streams between them are reliable and performant. Now the logistics world is also an event-driven world, so it makes sense to use event-driven architectures at the core of our integrations. So let's take a quick look at one of those event-driven integrations. When a parcel gets registered into our systems, like what you see on this slide, this generates an event. And the event is routed by the event broker and consumed by the delivery planner application, which generates a transport plan. And the plan is put onto the event broker again, but this time it's routed to many applications, the ones managing in-store pickups, the ones managing the distribution centers, and the ones controlling the delivery drivers, and of course a number of financial services as well. Then when the parcel arrives at the sorting center, it is scanned in the different stages of its journey. These moments where they're scanned are called observations, and the observations are sent to the event broker as well, which forwards them along to the sorting controller. And the sorting controller sends instructions back to the sorting line, to delivery planning applications, and a few other applications as well. Now, we only looked at one or two examples of events generated by a single parcel. But as we're moving more than 1 million parcels per day, and each of these generate way more events than we just saw, we're getting into serious event volumes. So in June 2021, we processed about 3.5 billion events in a single month. And of course, not every day is equally busy. So it peaked out at about 170 million events per day, or about 6,000 events in a single second. In December, which is generally our busiest month, the volumes are way higher still. So in December 2020, we saw 5.7 billion events being processed, peaking out at 280 million per day and about 10,000 events per second. Now the logistics world is also a highly competitive world. So to stay ahead of the competition, we need to build the features that our consumers want and desire. And of course, we want to have a quick time to market for those features. What we're currently seeing is that about 1 in 3 features that we build at PostNL require some form of integration. And that will likely remain true for the foreseeable future. So as our business grows, so does our application landscape and the number of innovations and the number of integrations. So to stimulate this growth, we also need to modernize our event broker. Now we don't know exactly what the future might bring, but as the amount of parcels grows and our processing volume grows, and we as PostNL are becoming more of an innovative tech company, the amount of events that we process might actually explode. So our systems need to be prepared for this increase, and we're currently designing for 14 billion events per month. And we're designing for peak rates of 20,000 events per second. Now we believe that the best way to stimulate innovation is by getting out of the developer's way. So my team, the integration team, we want to help those developers and we want to guide those developers, but they should not depend on our time and availability to build new products and services and the integrations needed for it. Instead, they should be able to produce and consume events as they see fit, and we should provide the tooling to enable them to do so. Yet we also work in an environment where availability and reliability are extremely important. Because if we fail to deliver events, or if our events are malformed, then entire distributions might halt, trucks can't drive, and of course consumers would be unhappy. So as everything in business, it's a balancing act. Now, before we do a deep dive into the technology, let me quickly summarize a few terms that I will be using a lot. What you will see is that those terms have a lot of overlap with terminology used in the logistics world, but from now on we'll be really looking at these terms in a technology context. So the first term is producer, and a producer is any application that sends events to our event broker. On the other hand, we have consumers, and of course consumers are any application that receive events. But an application can also be both a consumer and a producer, where they receive events, generate some action, and then send out events as a producer as well. Then an event or a message itself is described as an immutable self-describing set of data published onto the event broker. And by immutable, we mean it's a snapshot of a historic moment in time. An event happened, and the event itself cannot change anymore. So the event put onto an event broker describes that historic moment in time. And it's also self-describing because the event itself has the context. You need to understand that event. Generally, we don't have systems where you need to fetch additional content from some sort of web service. The event itself should be able to be consumed by itself. And the final term we want to introduce is schema. And an event schema is the definition of an event structure. So imagine an event which has 3 fields, for example, address, weight, and signature required. Then the event schema defines these are the 3 fields the event contains. These 2 might be mandatory and the 3rd one might be optional, and it defines the type of those fields. So for example, the address is a string, the weight is an integer, and the signature required is a boolean. And the schema really allows us to communicate from the producer's end what the consumer might expect from an event, and so they know how to parse it. Now, the goals we want to achieve with our modernized event broker are really summarized in 3 points. It's reliability. We want to be able to guarantee event delivery and the structure of those events. We also want flexibility, so we want to be able to dynamically add producers and consumers to our event broker. And we are a data-driven company, so we also want very comprehensive insights on what is being produced and consumed. And that involves exactly which volumes of events are produced by which producers, what the size of those events are, and which consumers are receiving those events. Now, the simplest solution to achieve this would be to allow producers to publish straight onto EventBridge. And we chose EventBridge as our message broker solution because it automatically scales to almost any capacity, and it allows consumers to filter and receive the messages they want from the EventBridge, from the event broker. However, EventBridge does not support schema validation, which means that producers could produce any event that they want, any schema that they want, and they could change their schemas over time, and EventBridge has no control over that. Now, this would break the reliability principle because the changes that they might apply could be incompatible with what the consumers receive, and that might lead to production outages in the consumer applications. So with this solution, reliability is a bit lacking. Flexibility, of course, is great because we can publish any kind of event that we like. And the insights that we require are lacking as well, and we still need to do a lot of work to get the insights that we require. So to improve on this design, the first thing we do is to add API Gateway in front of EventBridge. And API Gateway has out-of-the-box support for request validators based on JSON schema draft 4. So we create a path, a URL path per event type and version, and then we apply a request validator on that path. And with this mechanism in place, we can guarantee that any event on the event bus matches the schema as it is defined by the producer. And then when new event types or versions are added to the event broker, we add additional paths to API Gateway, and each of them get their own request validator as well. We also add the same schemas to the EventBridge schema registry, which will later be used for event discovery. So event discovery is the ability to fetch and read a list of available events on EventBridge, which will be used by consumers. We'll talk about that in a bit. Now, this solution with API Gateway greatly improves reliability because now we can guarantee that the events published onto EventBridge match the schema published in the schema registry. It also improves insight a bit because now we know exactly which events are published because they're published on these specific paths, and we know exactly which schemas belong to those events. So now let's talk about consumers for a bit. With the events stored in the EventBridge schema registry, consumers can discover which events are available to them. And this includes their schemas, so they know exactly what the data they will receive will look like. And because we apply schema validation at the gate, we can guarantee that every event on the event bus will adhere to this schema. When the consumer has found one or more events that they want to receive, they can configure an EventBridge rule. And the rule defines which event should be captured and where they should be sent. Now, we currently support 3 targets. The first are HTTPS endpoints. The second are EventBridge message buses in the consumer's own account. And the third are SQS queues in the consumer's own account. And all of this matches the basic functionality of EventBridge pretty well. So let's turn up the complexity dial a bit. First, our API gateway is available on the public internet. So to make sure that only authorized producers can send their data to our endpoints, we have created a client certificate vending machine. And this service uses a self-signed certificate authority to generate client certificates. And we then bind these certificates to a specific path using the common name and a custom Lambda authorizer, which means that these certificates can only be used for their assigned endpoints. Now, the reason we use client certificates and not IAM is because not all of our producers are in AWS. And PostNL has historically standardized around client certificates. There are some inherent problems with client certificates, specifically the fact that they are long-lived and they have an expiry date, so you need to replace them at some point. So we'll be looking at alternative solutions like IAM at a later stage. But for now, with client certificates in place, we have improved reliability because we can now trust that any event published onto EventBridge is published by a trusted producer. Flexibility is still good because we can add as many events as we like, but insights are still lacking because there are a lot of moving parts here without proper observability. Now, another artifact of our existing PostNL landscape is that not all events are as small as they should be. So 95% of the events is probably very small, like around 4 kilobytes, but some outliers can be 400 kilobytes or more. And we still want to be able to send those events over our event broker, but EventBridge itself is limited to 256 kilobytes per event. So to solve this issue, we put a Lambda function in between API Gateway and EventBridge. And we call this function the ingestion function. The function will measure the event size. It will publish the event to EventBridge unchanged if the event is smaller than 200 kilobytes. But it will offload the body of the event into S3 when it is larger than 200 kilobytes. And when this happens, the Lambda function will generate a signed URL to that object in S3 and put that onto EventBridge instead. But when this happens, we're mutating the event structure. And as I said earlier, reliability of the event and the event structure is super important to us. So how can we change the event structure, but still do it in a reliable way? Now, to understand that, we need to look at the event envelope. And we'll start by looking at the original event. So this is the data that the producer wants to publish onto the event broker. It's a nice and simple event consisting of a postal code, a house number, and a weight. We ask from our producers, and we enforce this through the API Gateway request validators, that the producers put the original event into a PostNL envelope. And the envelope dictates that the original event is put under the data key, as you can see at the bottom. Well, another object called metadata is added. And the metadata must have a PostNL correlation ID, which we use to track the event through our systems, and the original time the event was generated. The PostNL correlation ID and the event date time are mandatory, but the producer can optionally add an object of event attributes, which are key value pairs. And we guarantee that we will never strip those attributes from the event. And we will see why this is important in the next few slides. Now, the producer sends the PostNL envelope, including its metadata and data objects, to API Gateway and then to Lambda. And API Gateway and Lambda have a 5 and 6 megabyte event size limit, respectively, so they can easily handle those large events. Now, when the event arrives at the ingestion Lambda function and the event size is under 200 kilobytes, we set the event truncated field to false, and then we forward the event to EventBridge. But when the event is larger, we drop the data key. So as you can see on the right, the data key no longer is part of the event. And the details of where to find the original event are added to the event truncation header. And this is received by the consumer, and then the consumer knows that the event is truncated through the Boolean, and they know how to find that event, how to retrieve it from S3. And this is really where the event attributes come in, because EventBridge natively supports filtering on any key in the JSON body, including the data part. But our consumers can no longer rely on the data object being available, which means that they cannot reliably filter on any fields in that object. So by copying the event attributes into the metadata section, our consumers can always use those event attributes for filtering. Now, with the large body offload in place, we have further improved flexibility, because we can now handle a much larger variance of events. So we have achieved high reliability, we have high flexibility, but our insights are still lacking, because we have no idea which events are being produced, what kind of event volumes we're seeing per event, and we have no idea what our consumers are consuming. So this is a good moment to introduce the second responsibility of our ingestion function. Because EventBridge natively has no support for event level metrics. In fact, it doesn't even register the number of events sent to it by producers. Rather, it only registers the amount consumed by EventBridge rules. And it doesn't register the size of events at all. But our ingestion Lambda function knows exactly which events are coming in, and it knows exactly what the size of those events are, because it already measures those to determine whether it should offload them to the event bucket. So for analytics and cost control and optimizations, we would love to have this data available in CloudWatch metrics. But there's a problem, because the API you would use to write this data to CloudWatch metrics is the put metric data API. And that API call costs $1 per 1,000 requests. So for the projected 14 billion events that we would process per month, this would translate to $140,000 per month just for this single metric. And we can't even generate that cost and that metric if we wanted to, because the put metric data call is rate limited. Now, an obscure but very powerful feature to solve this is CloudWatch Logs Embedded Metric Format, or EMF. EMF allows us to write logs in a structured JSON to CloudWatch Logs, and then CloudWatch will convert the data in that object to metrics for free. So you only pay for the ingestion and retention of those logs, which at the 14 billion event volume we described earlier would translate to about $2,000 per month, which is very acceptable. So let me repeat that. At 14 billion events per month, the put metric data API would cost us $140,000, while with EMF it would cost us $2,000. This is a 98.6% cost saving for exactly the same metrics. So let's look at a bit more detail at how EMF works. On the left, you see an example of a log entry generated by our ingestion function. As you can see at the top, it has a key underscore AWS, and then it contains the keys timestamp and CloudWatch metrics. The top part, anything in the underscore AWS key, contains the specification of the metric that you want to send. So it has the namespace, it has the dimensions, which are the producer ID and the event type, and it specifies the metric itself. So it says the name is called size and the unit is bytes. And then at the bottom, you provide the actual values for those keys. So producer ID is truck, event type is event B, and the size is 526 bytes. Now just writing this log file to CloudWatch logs will automatically generate the CloudWatch metrics you see on the right. So we see the custom namespace, event broker e-commerce. You can see the dimensions, event type, and producer ID. And when you click that, you can see that there are 3 event types for 3 different events. So event A, V0, event B, V0, and event B, V1. And you can see the metric name, size is available for all of that. And you can use those metrics like you would use any metric in CloudWatch. So you can use them to generate these charts, or you could put alarms on them, and you could apply anomaly detection and so on. So with these metrics in place, we can really monitor what our producers are producing. And as I just said, we can apply anomaly detection, we can place alerts, and we could use it to apply some pressures on producers who are sending very large event volumes, especially the kind of producers who are sending very large event volumes with very few consumers, or maybe even no consumers at all. So the next question is, how do we find out which events are being consumed by which consumers? So we would like to know per consumer what's being received. And these statistics are not generated by EventBridge, so we will need some sort of custom solution. And to understand this solution, we first need to look at how EventBridge rules work. So EventBridge rules can be configured with a filter, which specifies which events they will receive, and up to 5 targets, which is where those targets will be sending their events. Now, best practice is to configure only a single target per rule. And if you need fan out, if you need to send it to multiple targets, make that target SNS or step functions or another EventBridge event bus and do fan out from there. Now, those EventBridge rules, they have metrics that tell us how many times that rule was invoked. In other words, how many events are being consumed. But they don't tell us which events are being consumed. And because the filters on the EventBridge rules support wildcards, it becomes difficult to statically determine which events a consumer receives. Now, to solve this problem, we add a second target to every EventBridge rule. And this target is configured to parse the event, filter out the source event from the producer using an input transformer, and then write the source event plus the name of the consumer to CloudWatch logs. And this is what those CloudWatch logs might look like. So as you can see, there are 3 fields: the consumer rule, so that's which consumer is receiving this event, and the name of the original event specified by an application, and the event type. And the application in this case is really the producer. Now, as these logs are available in CloudWatch logs, we can use CloudWatch logs insights to actually query those logs. So an example event is shown here at the top, and one of those queries that we could write is shown at the bottom. And what this query does is it takes the fields application, event type, and consumer rule, then it filters the application sort, so that's the producer, and the event type, event A-V0, and then it generates stats on the number of events being received. And running this query in this example over the last 15 minutes will show you that this event was consumed by 3 different consumers, consumer rule 0, 1, and 2. And you can see on the right how many times those rules received events of this type. And as you can see, the number of events is actually a bit different between the 3 because the filters between those different consumer rules might vary. So we already had great reliability and flexibility, and now with EMF and CloudWatch insights in place, we also have great insights into the events streaming through our event bus. So quick recap of what we discussed so far. On the left we have API Gateway, which is used for request validation and authorization using client certificates. And then we have the ingestion function used for large body offload and to generate producer metrics. And on the right we have the EventBridge rules, which generate consumer metrics, and those are sent to CloudWatch logs as well. Now at the beginning I said I would introduce a bit of CDK as well, and that's what the last few slides are about. So we have seen all the components required to create a reliable, scalable, and observable EventBridge architecture. And in the last part of this presentation, we will cover how producers and consumers can actually deploy the components required in this architecture through a self-service portal. Now, an important starting point is that all the components we covered today can be defined as CloudFormation resources. And this allows us to deploy the same infrastructure in a testing environment. We can apply rollbacks, and we have many other benefits in using CloudFormation as well. So the CloudFormation template is our single source of truth. But this introduces a challenge because because the producer should be able to define their own API routes and events, and consumers should be able to define their own EventBridge rules and targets. And how can they manipulate this CloudFormation source of truth whenever they want to deploy a new component? Now the missing piece in this puzzle is the CDK, because the CDK allows us to generate CloudFormation templates, including the dynamic resources we require through a programming language of our choice. And this programming language is a high-level language. So we can do all sorts of cool stuff like reading configuration files, connecting to external databases, or communicating with external APIs, all as part of our CloudFormation generation process. So we've built a separate product, which is the management application. And this application is used by our producers and our consumers. They define the endpoints and the consumer rules that they want, which are then validated and stored in a database. And when the validation succeeds, we trigger a CDK deployment, which fetches this configuration from the database. This allows us to have a single source of truth in CloudFormation, yet we can manipulate that truth with dynamic and user-friendly APIs and graphical user interfaces. The APIs also manage authentication and authorization, so we can control who can deploy what, and we can add 4 or even 6 eye reviews to protect sensitive data on our event broker. Now, apart from the create and update actions, we also have read and list actions, such as querying which users consume an event or the latency of the event bus. Now, these queries are forwarded directly from the API to CloudWatch or they are fetched periodically and then stored in the database. So this concludes the current state of our event broker. Looking at what we will be working on in the future, we want to reduce latency. And latency in this case is really the time it takes for an event between an event being produced and it being received by the consumer. There's a certain amount of time, and every component in our architecture adds a bit of time to that latency. Now, EventBridge itself introduces a bit of latency, and I've talked to the EventBridge team at AWS, and they are actively working on reducing this latency in EventBridge. But also every component that we have in between, such as API gateway and the ingestion Lambda function. Now, those are components that we can influence, especially the Lambda function. So, for example, we might rewrite that function in Rust. It's currently written in Python. And do further optimizations there as well. Another thing that we are looking at is to reduce the number of components. As you can see in the architecture diagrams, we already have quite a number of moving parts, and anytime AWS releases a new service that replaces the functionality that we built ourselves, we will try to use those services built by AWS instead. And the final thing we're looking to do is to reduce the non-cloud native integrations such as HTTPS and client certificates and replace them with more cloud native integrations such as SQS, SNS, and EventBridge as well. But of course we need to work with the teams using our event broker to achieve that. So to conclude, EventBridge is a really powerful and flexible event transport layer, but it was really built for this flexibility. So it allows producers to publish any event and any event schema. And it's also kind of limited in its monitoring capabilities. So as we see so often in AWS, a single service, in this case EventBridge, does not fulfill all of our business requirements out of the box. To reach our goals, we need to integrate with many other services such as API Gateway, Lambda, and S3 to achieve those business goals. I hope my talk gave a look into the AWS Solutions Architect approach, which is looking at the different services available to us, see how those services solve specific problems, and how we can combine them to reach our business goals, all the while balancing cost and performance. And that's it for me. Thank you for your time and your attention. And if you have any questions, I'd be glad to hear them.
Luke, thank you. That was fantastic, and I'm sure I can say for everyone here that there's things they can take away from that. I mean, I probably know more about EventBridge than most of the attendees, and even I've learned quite a few new things in that one, so thank you very much. Got a small number of questions coming in, but hopefully we'll get some more as I walk you through those first ones. But no, that was really, really insightful, so thank you. So one of my kind of questions, my job, I'm always thinking about what's the worst case scenario. Everything that our business ever does is what's the worst case scenario. So how do you use this in a disaster recovery setup? Do you have another region that it can automatically fall over to? Is that something that's on the to-do list? Or, because I appreciate with event-driven computing, that's not the simplest option probably, is it?
Yeah, so we do use EventBridge archive and replay. So that allows us to at least store the events in case of an outage. Make sure that we can replay them later, both in our core component and in our consumer component. So if a consumer is not available, they can replay the events that they missed later. We don't actually have multi-region resilience. The idea there is if Ireland goes down. We're completely focused on the Ireland region. And AWS goes down, and then there are so many services depending on that, that even if we're still online, if the event broker would have a backup, for example, in Frankfurt or Paris or London, the entire business would still not be up and running. So I guess we'd have to have a complete multi-region setup for the entire application landscape, and that's not something we're currently investing in.
It's a lot of effort, a lot of expense, and I can entirely understand that. So, a couple more questions. So you showed that you deployed producer and consumer config through the CDK. So, I mean, how does that scale? I mean, any new producer or consumer results in a deployment? So, I mean, how do you approach the deployments of that?
Yeah, so at the beginning, when this environment was smaller, we put all of this into one single CloudFormation or CDK project. The idea is, if you have producers and they have components in API Gateway, it makes sense to have those components in the same deployment as the core API Gateway itself, because there are many integrations there. But that means you get a giant CloudFormation template with hundreds of substacks and thousands of resources, and that becomes really slow to deploy. So in a later stage, we actually separated that. We have a core application that consists of, let's say, an empty API gateway and also the ingestion function and the EventBridge. And then we have separate deployments, separate stacks that just have a reference to that API gateway and to that Lambda, but deploy as standalone stacks. So anytime a new producer is added, a new stack, a standalone stack is added, and the deployment of that is really really fast. And we can add hundreds or thousands of producers as separate stacks that way.
No, it makes perfect sense. I feel the pain on the CloudFormation and the, okay, you've done 3/4, I'm going to roll back now and all sorts of things. Yeah, the speed impacts totally. I had a couple of questions come in about cost, actually, just while you were talking about there. So both of them are asking the same part of what the most expensive part of the service is. You know, you use Lambdas, EventBridge, and others. And do you know what your cost per event is? I'm assuming it's like Amazon, it's 0.0000, something ridiculously tiny. But what is the most expensive components?
I can't tell you the cost per event directly. It also depends on the size of the event, of course. I do know what the most expensive component is. Do you want to take a guess?
I was going to say maybe that initial Lambda that does the no,
it's API Gateway.
Good point. The per request fee.
Yeah, because API Gateway costs $3.50 per million requests, and that's actually pretty expensive. The HTTP API Gateway is a lot cheaper, but it doesn't support the request validator, so we have to use let's say the old REST API Gateway, and that's more expensive. An alternative that we looked at is actually to not do the request validation in API Gateway, but do it in the ingestion Lambda function. I mean, there are just Rust libraries or Python libraries that can do it for you, but that would mean that we would take the responsibility for those request validators and all the code involved as well, instead of just handing that off to API Gateway. So it's again, it's a balancing act between what you want to build yourself or what you just simply want to pay for.
No, absolutely. Which, interesting enough, one of the other questions that just came in was, what does the EventBridge itself give you? It looks like you could build most of what you need yourself. So why have you chosen, and you made it very clear, go down the Amazon managed services route rather than self-building. So what is it that drives that decision for you?
Yeah, so two functionalities in EventBridge that we really like are the filtering options, so that you can just specify a subset of the events that you want to receive. For example, we have distribution centers across the Netherlands, and we might have a single event type, for example, I don't know, parcel received, whatever. And 5% of those millions of events are meant for one distribution center, and 5% are meant for another distribution center, and so on. And that's specified in the event. And EventBridge really simply allows us to specify filters to say, hey, anytime you receive this event for this depot, route it there, and then route it there. That's really like 2 lines of code using EventBridge, and that's really the kind of responsibility I'd gladly give to AWS to manage for me, instead of building this entire filtering system ourselves. And the other one is replay. So that also is like 1 line of code to enable replay, and then you can just use the AWS APIs to select the exact date range and the exact kind of events that you want to send to an exact consumer. So when one consumer does a replay, it doesn't affect the other consumers at all. Now, that is pretty complex to build yourself, and we gladly use what Amazon has available for us.
No, absolutely. I very much agree. I've run a few kind of messaging systems in my time, and it takes away so many headaches from these kind of things. It's worth the money for Amazon to run it. As you say, the scalability is incredible. I mean, Amazon has their own limits, which you can obviously ask to get raised where appropriate, but the sheer scalability of it is amazing. So a couple more questions.
It was actually kind of funny when I was designing the solution for EventBridge. I was looking at the limits, and it said, well, in Ireland the base limit is 20,000 events per second, and you can raise it up to 100,000 per second, and above that you need to contact support. I was like, well, we might hit that 100,000 per second, so how does that work? So I contacted AWS, and they said, yeah, we really just want to talk to you if you're doing that kind of loads, because we just want to understand your business, but there's no real limitation at 100,000. We can raise it up to anything you like. So that's really nice.
Yeah, fantastic architecture. They must be able to do that entirely. Yeah. So another question, we talked about event bridges and kind of touched on event buses. Do you just use the default event bus? Do you have multiple event buses for different reasons?
One single custom event bus. So we do use the default event bus for scheduled events and the like, but this is really our own custom event bus. But we do have one single event bus that routes all of the events, because that really helps in event discovery. If you want to see what events are available, it doesn't help if you still need to go across 10 event buses to find them. You really want to have them aggregated in a single bus.
No, 100%. Discovery is a huge part of it. The project, the software we're building internally is analyzing Amazon-produced events rather than our own kind of producers. So there's a lot of, what does this event look like? And you go and look at it in the Amazon documentation, it doesn't exist. You have to actually go and find an instance of that event that exists to actually then be able to work out what to do with it. So no, I totally feel your pain there. So what question on the EMF implementation, is that centrally controlled deployed, or the individual service teams and devs configure their own metrics based on that? So yeah, that makes sense.
No, we collect the metrics. So we have a specific set of metrics that we collect per event, and we deliver them to the producer and consumer teams through a dashboard. And if they require additional metrics, then of course they can request them. But really, we have to look at the cost benefit there, because one additional metric times 14 billion can really run into high costs if only one producer needs it.
Oh, Yeah, and your point about the cost of using the metric data instead that's a fantastic tip for anyone that's looking to do that. We've come across a few customers that CloudWatch just sneaks through these giant bills without you really understanding where they're coming from. So it's a fantastic. We're just slowly running out of time here, rapidly so, because Luke is a hard stop at 2, so I've got maybe a couple more questions at most, and then we'll probably have to call it there to let you get on. So I said, look, your talk looks very polished, and you talk about how you overcame problems. The whole solution is very polished. How long did this take to design, and what was the process like?
It took about 2 months to design, and I think the process is much like collecting requirements first, like availability, scalability requirements, volume requirements, things like how large should messages be, things like how do we build integrations like the HTTPS integrations, the client certificates, collect all those requirements, then start designing a solution and around it. And there's a document, I think the design document for this is about 40 to 60 pages, somewhere around there. Lots of text, lots of designs and graphs, and then discussing that design document with the stakeholders, describing the solution, reworking it based on their feedback, and then finally, when everybody feels like the solution will solve the problems and solve the business requirements, then you start building, and building from scratch to, let's say, MVP is 4 to 6 months. And then another 6 months to get to full production capability.
Yeah, it's a fantastic engineering effort. It's a really, really exciting project. I'd say the sheer scale of it is something to be very proud of. I certainly sort of think so. So one, just kind of going back a little bit in terms of what you said about one of the real benefits of EventBridge is people to go, I want to see those kind of events, and even better, you're not taking that away from somebody else. Someone else can also listen in for their own things that match the same event. It's really, really powerful. So when that comes to personal information, is there any personal information that gets sent? Well, obviously names and addresses even are personal information. So how do you manage that the control of that, so you don't have data through this method?
Yeah, that's a really interesting topic. I'll try to answer it as quickly as possible. We allow producers, when they register events, to mark whether the event is sensitive or not. So, for example, if you're sending some sort of heartbeat or deployment started or deployment succeeded event, that's not sensitive. Anyone can receive it. If it's not sensitive, consumers are free to deploy a consumer rule and start to stream that data to wherever they like immediately. If it is sensitive, they can specify where they want to receive that data at a specific URL or specific queue, and a approval request is sent to the producer, because the producer is the data owner. And they should verify, is this a valid use case and where is it being sent? Is it not being sent to, I don't know, somebody's basement? Somebody thinks, hey, I'd like to copy all the credit card data into my personal S3 bucket. Well, that's something that will not be approved. And only when it is approved, those events start streaming to that consumer. And we also built it in such a way that those subscriptions cannot be updated. So they're deployed once, and if they want changes, they need to request a new subscription.
No, that's a really great insight, and that's part of your tooling on top, obviously, that you built, and that's fantastic. So I'm going to call it there on the questions, because Luke does have somewhere else to go, and I appreciate we've taken up his full hour already. So thank you very much, Luke. Thank you very much for everyone that's attended. It's been a really successful event from the attendance perspective. So much wider audience. We've got people from all over the world I've seen in terms of the sign-ups. So thank you very much indeed. Pleasure to have you.
Thank you for having me, James.
Thank you.